welcome back to my channel, and today we are going to continue programming the shield support part, and it is going to be part 2 is going to be finishing operation. So in the part 1 we roughed the whole part using different methods using multi-axis pocketing. So if you want to find out a bit more about multi-axis pocketing, see the first part of this tutorial. And before we move on to our first programming operation, I want to show you that I've changed the step over a little bit to a little bit tighter on this toolpath, just to have better base for our finishing operation. Also, I'm going to create a stock model as a result of our all previous operations, and that I'm going to use as an initial stock for our simulations. So we've got one stock here, and that is calculated from these two pocketing operations. So I can use it as an initial stock. So my initial stock is going to be stock model number 2, and I need to add only these 3 operations. Okay, and let's compute the stock model from the roughing ops. Okay, so this is our stock model. It is result of our roughing operations, and now we can see what we've done in the first part of the tutorial. Okay, so first thing, I can see that we could actually trim a little bit those steps here on the side to have more even material to finish here. So let's have a look how much material it is on it. So let's go back here, parameters. I'm going to stock definition and change that to the glass material, and I want to be able to see through the stock. Okay, so you see that we have actually quite a big step here and a little bit of steppy material, so you have various resistance on the tool while machining this. So I'm going to trim this, and this is going to be first operation. I'm going to use swarf. Okay, before I set my swarf operation, I need to create some wireframe geometry, and I created a new level number 4, swarf wireframe, and I'm going to curve one edge. Use this from wireframe tab to create some lines, but before that I need to make that one active, so everything what I create now will be saved on this level here. So let's go, and we need to create, so that would be my bottom rail and the top one, and I'm going to do the same with this side. Okay, and this will be my bottom rail, and that will be my top. Now from toolpath gallery, from my application swarf, not this swarf milling, I'm going to use a swarf here from the application. I'm going to use 20mm slot jaw with 2mm rad, so I need to go at least 2mm deeper to accommodate this corner radius. Stock model, I'm not going to use the stock model for this one. On the cut pattern page, we're going to define our wall, and I'm going to use chains to tell Mastercam where is the top and where is the bottom of the wall. And the first chain, Mastercam want to know what is the direction of the pass, and also which one is the bottom of the face. Okay, so I want to start here, and then my upper contour is going to be that. Okay, you can use only wireframe mode selection, that's why we created those wireframe. You cannot use a solid mode selection. Okay, so cutting method is going to be one way, and the compensation to be left. I want to leave stock of 0.15 for my finishing toolpath, and I'm going to leave those as default settings. I don't need to do anything better, it's just a pre-finishing operation. And instead of entering at the middle of the first wall, I'm going to enter at the start of first wall. Okay, so now let's go to tool axis control, and output format I want 5 axes, and the buck plot rotary axis is Z. My rotary axis is on Z. Okay, so this is my rotary axis. I'm going to leave this rest of the settings on this page as my default settings. So let's move on to collision control. So first, tip control, I want to be based on the lower rail, and I want this distance above lower value to be negative, so my cutter will go deeper than the lower edge instead of staying above this edge. So if you put positive value, the cutter will be above that bottom line, and if you go minus, it will go deeper. And I'm not going to use any compensation surfaces or check surfaces at the moment. I'm going to add them on after if we have some issues, but we shouldn't have any. And also I want to show you this option here, oscillate. Okay, so if you cut a lot of parts using this swarf toolpath and you have like a thin section you cut all the time, like an edge or something, it would create a quick wear on one point of your cutter. So to extend your tool life, you can introduce oscillating, so the cutter will move up and down while moving along the contour here, and I'll show you how it works. So amplitude is how high you want to oscillate as. Okay, and I'm going to put as 20 millimeter. Okay, and the distance, so what is the distance between start and the 8 of the one full oscillate, I'm going to set this up as 35 mil for now. And you can do it as a high speed, so it will be, oh, actually you'll be able to see it. So this is the linear, so you have sharp point, and this is the high speed. Okay, and the linking parameters, I'm going to leave those as default at the moment, and I'm going to use some entry and exit, and I'm going to activate entry curve, always use, exit curve, always use, and I'm going to get to do something smaller like 5 mil here, and I'll copy all these settings to the bottom, to the exit curve. Okay, so we have entry and exit the same. I'm not going to set at the moment any safety zone in the roughing, maybe because we have quite big steps. I'm going to add 1 roughing and maybe 2 rough, or actually one. I can add 1 roughing and 1 finishing, so it's going to be 1 rough, doesn't matter what spacing, and 1 finish pass. For the finish cut, I'm going to do like a 0.5 mil or something. Filter, I'm going to leave that unticked. Planes are top. Can add coolant if you want. And this is it. This is my tool path. So as I mentioned, our tool will oscillate along the cut here. So this is how it looks like. Okay, let me double check how this toolpath looks like. Okay, so we have this oscillating motion, and nice. Oh, I don't like that. And it is because one of the lines is probably longer. That's correct. Okay, so let's quickly fix it. I'm going back to parameters, and in cut pattern page, I'm going to remove my wall definitions. So I'm going to reselect my chains. In this box, simply right click, mouse button, and select rechain all position. And now instead of selecting closed chains, I'm going to use a partial, and let's select the first as our lower edge of the wall. So we start here, and this time I want to finish on that point, both of them. After that, we select the second chain, which represents the top edge of the wall. Note that both our chains now finish in the same point, so they are the same length, so we shouldn't have this rotation at the end of the motion or of the cut. Yeah, okay. So now I can quickly copy that below, go to parameters, remove chains, select new chain, right click, rechain all, and this time I'm going to actually do it from this side. So the compensation is left. So I'm going to do that. So lower edge, then upper edge, and this is my toolpath. Regen. Okay. So 1, 2. And it's going to be quite a lot of finishing toolpaths to finish all these bits. So I'm going to divide it into sections. Okay. So let's call that an open pocket. I'm going to create a new group. And now we have our 2 new toolpaths inside the open pocket toolpath group. I'm going to finish those walls inside this pocket, okay? And for that, I'm going to use this new toolpath, this unified toolpath. So now, as I mentioned, I want to finish this open pocket, and I'm going to finish that with all the fillets around, only around this pocket here. So for that, I'm going to use this new unified toolpath that CNC software added to this release of Mastercam. So it's 2022. So let's go and select unified from Multiaxis gallery. And I'm going to use ball nose end mill 6mm. Holder is already pre-selected from the tool library that I already gave you to download. And the stock, I don't want to use stock as I want to machine the whole pockets pass by pass without breaking the cut, if you know what I mean. So I'm not going to use a stock. I want to machine all the faces that I'm going to select. So this is the pattern window, and this is how you control your machine geometry. So you can select the automatic. So first we are going to use automatic, and then we're going to use 2 curves and select some morphing strategy. And we're going to set the morphing strategy on this one as well. And the style of the toolpath you set here. So we have machine boundary, and I'm going to select morph. And I'm going to use a morph from one side to another. Let's just compare the differences. And here I'm going to use 1/2 mm as a step over. I know that for the finishing toolpath it should be around maybe maximum 0.1 to get really good finish, and the cut tolerance should be a lot tighter. And also, if you want to get a better finish with this toolpath, you go to advanced option for surface quality and select the point distribution, activate the maximum distance and set it to tighter value here. Okay, so I'm going to leave these settings as default settings. So these are my settings here, and in the tool axis control I'm going to use a 5-axis strategy with surface with tilt. Okay, and those 2 I'm going to leave as you see here. But what I want to do, I want to limit the rotary movement or the tool axis change. I want to use with the tool lock to the tool axis from to one position. So I'm going to use this common direction. Okay, but just in case if the tool, because we selected only pockets, Mastercam doesn't know where are the other surfaces. So I'm going to quickly add a strategy for the collision check, and I'm going to retract the tool every time if the tool goes too deep into machining geometries or in avoidance geometries. And as my avoidance geometries, I'm going to select the faces around. Okay. Okay, so these are my avoidance geometries. And now in the cut pattern page, I can select my machine geometries. So even if you have this strategy to do automatic, you still need to tell Mastercam what faces you want to machine. And with this button here, you select all the faces that you are planning to machine in this operation. So I want to finish all these faces around here. And when you select in those faces, don't forget to select those tiny bits as well, if you follow the tutorial. Okay. So this is the selection. And now we have everything set up on this page. Everything set up here, what we need. Collision control we have set up as well, some avoidance geometry, machine geometries. I want to set something in linking as well. So I want to first add lead in for the first entry, and for the last motion, last exit, I want to use lead out. Let's move on to default linking. And for large gaps, I also want to use lead in and lead out. And for the small gaps, note that for the small gaps, I don't want to use lead in for any small gap size that are smaller than 100% of my tool diameter, which is 6 mm. Okay, and my default lead in, lead out, I'm going to use automatic arc with tool axis orientation automatic for both entry and exit. Okay, so let's see the toolpath. Okay, so this is our toolpath. I'll pause the video for the regeneration time. And it looks actually nice, evenly spread. So let's have a look how this area here would look like. Okay. So for my simulation, I'm going to pick stock model 3. Yep. Okay. Let's go by verify. Okay, so now let's have a look into the compare. So my tolerance is 0.05, and let's compare it to the 3D model that is active on my screen. Okay, and as you can see, we have some little unmachined areas on the internal fillets. Okay, and remember that we are using 6 mm ball nose and the fillet is 3 mm rad. I think this result is great, and even if we have those unmachined areas, if we used smaller cutter and with the step over definitely smaller than 0.5 mm, I use that only for the video purpose, so you can see how the passes spread on the surface. And in the real example, I would use probably something about 0.08, maybe 0.1 if I use 4 mm ball nose cutter. I think this toolpath is doing a great job as an automatic pattern. So now, what I'm going to do quickly, just to compare, I'm going to copy that below. And in this toolpath inside, I'm going to change on the cut pattern page, I'm going to change the pattern. Okay, so I'm going to remove this and I'm going to use 2 curves. Okay, so I'm going to change the style to morph. Automatically change Mastercam changes to both of them. And in here, in this button, I'm going to add my first curve, and it is the pattern from in morph toolpath. So I'm going to use this single line. I'm using the solid mode selection and edges. Okay, so that's my first selection. And for the second curve, which is pattern 2, I'm also going to select one curve, and I'm going to select this curve on the other side. And advanced options for surface quality, I'm going to change that to exact. We didn't have that option in automatic. And rest of the settings I'm going to leave as on the other example here. So let's have a look and compare the difference, if there is any. So this is our toolpath. Okay. So as you see, when we move, Mastercam does some motion along the fillet here, internal fillet, and that I think will help to clean it up a little bit, clean the material from inside this fillet here. So let's have a look now at the simulation. So as you see, we are going from one side all the way down to the other one, and we do not change the tool axis of the tool. This looks interesting, and you see that this fillet inside is really clean. You can see the difference already. So I'm going to use the same compare options. And as you can see, the 3D model looks a lot cleaner. We do not have this yellow bits left over, and maybe the outside fillet is not going to be as good, but I prefer this result. Okay, so let's add one quick operation to just go around the fillets, and that would give us nice finish. Okay, so to finish those fillets, I'm going to use another multi-axis toolpath, and I'm going to use flow. I'm going to use the 6mm ball nose again. Stock is switched off. Cut pattern. What I want to cut. And of course, I want to cut the fillets that are going around. Remember, we have small surface here. We need to select that as well. And on the other side as well. Okay. So only fillet I selected. Okay. So I'm happy with the cut and step direction and offset and start, but what if that is not the case? Let's have a look into those flow data buttons. So if for any reason your toolpath looks like that, it's a big chance that your passes are generated underneath the surface, and you need to tell Mastercam to offset the toolpath to other side of the surface. And you might have a pattern that looks like this, and in this particular example is not the best, solution. So I would recommend to change the cut direction and to go along those fillets. I'm going to use one-way cutting method, but you can use a spiral or zigzag if you need to. Compensation is going to be left. This is the finishing operation, so I don't want to leave any stop on drive surfaces. And maybe let's go to 1 here, 0.01 here, cut tolerance, and the distance. I'm going to use 0.1 to get nice finish. Okay. In the tool axis control, I'm going to use a plane. Okay. In this example, you have different methods of tool axis control, and they are similar as in other multi-axis operations. But I'm going to use a plane. Okay. And it's going to be 5 axes. My rotary backplot rotary axis is Z. And I want to show you how you can select the plane for our example. So basically, I want my plane to be, my tool to be pointing from this direction. And I don't want to change the tool axis. I want my tool axis to be locked. So we'll be using like a 3 axis to the plane, normal to the plane that we are going to select. So at the moment, my plane is here selected, okay? So I'm going to use a 3-point, and I'm going to select 1 point here, 1 point here, and 1 point here. And this is our plane, okay? So I want to flip it. I want my retraction to be here. And this is how my tool is going to be orientated during the cut. Okay. I'm going to leave lead lag angle and side tilt angle as 0, and I'm going to switch off angle increment, collision control. I'm going to select some surrounding surfaces, just in case, as I don't want to hit any of those. Okay, so this is my selection, and now we can go and check our toolpath. Select OK, and let's have a look at the result. And this is our toolpath. Okay. So you see some green line here and here going like a sideways, but this is only the retraction leading going towards the part. Okay, so let's have a look if our tool is locked to a plane. So you see the tool is always the same direction. It doesn't change the tool axis. Okay, see, nice. That will give us nice result. Okay, so we have now our open pocket finished programming, and we can move on now to next section, which is this big pocket. So for that, I like to keep things organized. So I created another toolpath group and I named it big pocket, so I know what toolpaths are inside for. And I would like to start with cutting this top fillet using 5-axis flow. And of course, I could use the same method as on this fillet here, but I want to show you different option how you can lock your tool axis to one position without using any rotary axis. Okay, so how you can lock your tool axis to one position. And for that, I need to create extra geometry. So I created another level, and I call the flow tool axis line BP for big pocket. Okay, so I make it active. So every geometry now I'm going to create, it goes to to that level. And what I want to do is create a line normal to a point. And first, we need to select a face or this fillet. So I want to create a line on this face, okay? So left mouse button on this face. And I'm going to drag my mouse on top of the edge until I see this crossed line. That means that I'm halfway through. And I want to put my cursor on the top edge. So the line is 90 degrees to the surface, okay? So as you see now, the line is vertical. And the arrow is pointing up the way. That's fine. Now click OK. So at the moment, if we machine it like that, we would have our tool locked to the vertical position, okay? But I want to have orientation that is something between this angle and this angle of the wall. And it is because I want to create a toolpath where in this symmetrical pocket, my tool axis will be locked to an orientation that is roughly the average angle of all the walls. It doesn't have to be bang on, just roughly. So let's quickly measure the angle of each wall. So that is 70 degrees, okay? And also I'm going to check using Analyze Dynamic. You can find it also in Home tab, Dynamic. I'm going to check what's the angle of this wall. So it's 90, so it's 20 degree difference. So I want to tilt this line basically 10 degrees. And to do that, you go to Wireframe, and you have this Modify Length here. In the drop-down menu, you have this new option, Modify Vector, inside the Mastercam 2022. If you don't use Mastercam 2022, just click on the line and select Dynamic. Okay, but I want to show you how this Modify Vector works. So drop down menu, select Modify Vector, select the line. Doesn't matter where your mouse is, just select the line, and you can just tilt. We set 10 degree, so I want to tilt that 10 degree, and I'm going to use this line as my tilt line. And I want to show you something else that was added on to Mastercam 2022, and this is very useful. I use it now all the time, and this is how you can check the orientation of this tool axis, this line. So if you press on that Z letter above the Z axis, Mastercam will orientate the view so you can look down onto that plane from the Z axis. So basically you will see and you can confirm if the angle of this line is correct and if the visually looks okay. And I'm happy with this. Click OK. And now we can set our flow operation. So for that, as I said, I'm going to use flow 5-axis. So I'm going to copy that and paste it here. Okay, now I want to open parameters of this toolpath, and I'm going to change only a few things. So in cut pattern, I have to change my flow parameters. So I'm going to remove all my surfaces, and I'm going to select new surfaces, and I want that fillet, only fillet that goes around the top edge of the pocket. Okay, so as you see, we've got only the top fillet. Select OK, and let's select our flow. So I don't want to start from the bottom and go towards the top. So I'm going to change the step direction. And also I don't want to go this way. I'm going to go one way method, and I don't want to be on the right hand side of the surface, and I want to be on the left side, okay, on the compensation left. So I need to press this start button and we'll reverse the toolpath. And this is what I want. Okay. And rest of the settings I'm going to leave as default. And the collision control, maybe I'll just add change and add few check surfaces. You probably don't have to, but just to be safe, I want to select those surfaces around this fillet, okay? So this is how it looks like. So I've got this and the walls only. Okay, and let's have a look at the tool axis control now. As I said, I don't want to use this plane again. I want to show you how to use this line. So select the line. Now select this line that we selected as a tool axis control line, and remember to have the arrow pointing away from the surface, pointing the retraction direction. Okay. Okay, so let's have a look at the result. Okay, so we've got our tool path. So it's nice, equally spread. I'm happy with this. And let's have a look now if our tool is definitely locked to one position. I don't want to have any B axis or C axis rotary motion. So as you can see, the tool axis is locked to that position, the orientation of this line that we selected. Let's see from another view, still the same, and let's try to stop the tool on that line. So as you see, the tool is exactly how we selected the line. The angle and the orientation is the same as the line. And to get the finish, this is the best way, just to limit the amount of axis involved in the motion. I know that it looks fancy and nice when all the table and everything flips around, but you get nicer finish if your tool motion be smooth and steady. So if you select only one line, it will just orientate the tool to the orientation of the line. Of course, you can have multiple lines along this fillet, along these cutting surfaces, and you can change the angle on each position by using multiple lines. Okay, and to finish those walls, I'm going to use one of the previously set operations that we use for roughing this pocket. And it was, I think, this one? No, this one. Okay, so what I'm going to do, I'm going to reuse this operation and just change a few things. I'm going to copy that after this one. And I'm going to go quickly to parameters and reset a few things. So I'm going to use this 12mm 18-degree taper form cutter. And it has radius of 2mm on the bottom, then it has radius on the top 5mm, and the main radius that we'll be using to cut the walls is 200. After selecting the cutter, let's go to cut pattern page, and I'm going to change the pattern, the machine pattern, to finish walls, wall finishing. But as you notice, the ceiling was replaced with the walls. So I'm going to remove this ceiling, okay? I don't need this for this operation. And let's go to wall finishing. And now I'm going to select my walls, what I want to machine. So I'm going to machine the walls around this pocket. But because my tool has 2 mil radius and the fillet is also 2 mil, I'll try to finish as much as possible of that fillet going around. But mind that the wall and that is not 90 degrees, so it might cause a little bit trouble. But okay, So now I'm going to add those fillets to my machining walls, okay, to my walls library or to my walls section. So I've got now all those walls around and bottom fillet. Select OK. And I want to use strategy to go one way. And of course it's not roughing, so I'm going to remove the stock to leave on each position here. The surface quality, I'm going to change it to 0.025, but the maximum step over, I'm going to do, let's say 2.5 mil, let's say even 3 mil, okay? And now because we change our machine pattern to wall finishing, we have activated the tool axis control. And for this, I'm going to use my preferred contact point around 25, 26 degree, let's say. Okay, so it is 1/4 of the length, okay, of the cutting length. So here is a 0%, 100%, 50. So we are around here. Okay, and my minimum contact point, because we are using this cutter to finish also the fillet, I want to be able to use the very, very bottom contact point. Okay, so I'm going to add minimum point of 0, 26 here or 25, and the maximum, let's say something below half, so maybe 40. Okay, collision control. At the moment I'm not going to add an avoidance geometry. Let's see the result. But before we close this window, on the linking page, I'm going to change the clearance type to cylinder, and my cylinder is on the Z-axis, and I'll set here automatic. Or if you want, you can just right click here, radius on the arc, and select that. Okay, maybe add something. For lead in and lead out, I'm going to use something like 2 mil and minimum radius of 1. Okay, I'm not going to do anything here, we have nothing to change. And let's have a look at the result. Okay, and this is our toolpath. I paused the video and to be honest, it was a few minutes. Okay, so let's maybe have a look at the verify and how the toolpath looks like. I'm going to use a start position for my simulation as model 3, stock model 3, that's correct. And I'm going to simulate only this one toolpath. Or actually I can simulate them both. Okay. Okay, so this is my, oh my god, my 3D connection, the space mouse is failing again. I have to order a new one. This axis doesn't work. I can rotate it this way, but not that way. The mouse is okay, but when I'm trying to use space mouse, it's just, oh no, no, it's not. Okay, let's have a look into this simulation thing. Okay, so I'm going to compare the result of our simulation to actual 3D model that is active on the programming page, okay, on the main window in Mastercam. So first, let's run the simulation. And this is our barrow mill accelerated finishing tool. Okay. Let's have a look now at the result. Compare it to the 3D model. Okay, the result is quite good. You see all the faces are green, so they are within that tolerance. And actually, let's have a look if we can crop it. So yes, that's nice. The fillet is okay, the bottom fillet is okay, and the wall is finished. And also mind that we used 3mm step over instead of 0.1 with the ball nose to get nice finish. Maybe if we use a bigger cutter, we could maybe push it to 0.15, but it's still a huge saving. Okay, so let's close this window. Okay, so we've got our walls of the big pocket finish and also top and bottom fillet. So now let's try to finish the floor using the same toolpath with the minimum changes that you have to do. So for that, I'm going to use again pocketing cycle, and I'm going to show you how you can quickly reset your settings to get the tool motion you want. So let's go to parameters. And now I'm going to use the tool that is 4mm ball nose. Okay. The stock is still switched off. In the cut pattern page, I'm going to leave all these settings as default, but of course I want to finish the floor. So my pattern is going to be machining floor. Note that I'm not changing any surfaces, and my strategy is going to be offset from walls. But there is one thing I need to change, because I'm using a ball nose cutter. My step over has to be quite small. For our tutorial, I'm going to set it to 1mm, but of course in the real machining we will have to set up something about 0.1. Okay, so I'm going to set it to 1mm. And now let's have a look in the tool axis. So in this scenario, my wall is tapering towards the front, okay, and also my walls are tapered, and that is less than 90 degrees. So ideally in this scenario, I'll have to keep the tool that is normal to the surface, and this is what I'm going to set. So my minimum contact point is 0. I want to be on the very tip, okay, so my tool will be allowed to stay vertical to the surface, not to the axis, to the surface, okay. And my preferred position is going to be 0 as well. I want to cut at the 0 tilt as long as possible, and of course to avoid the collision, I'm going to let the Mastercam to tilt my tool about up to maybe 15 degrees, okay. And this is all I'm changing. I'm not changing anything else. Everything else stays exactly the same as on my wall finishing. So as you see, I only changed the tool and also the tool axis, okay. The cut pattern in the cut pattern page, only this has been changed. So let's generate the toolpath, and I'll see you in a few minutes. Actually, I'm going to pause the video so you don't have to wait with me. Okay, so we've got our toolpath. To be honest, it took almost 4 minutes on my equipment. So let's have a look at the toolpath. Okay, I can see straight away that something is not right with this, and you can see straight away that it's not what we wanted, basically. And it's not that you've done something wrong. That sometimes happens, and I found that strange, but let's go back and I'll show you how to fix it. So we are back in the pocketing cycle, and what I want to go is for reload parameters from default file. Okay, and now let's double check if the tool is the same. Stock, let's switch that off. Cut pattern, I want to do floor finishing. I'm going to use exactly the same setting. So it's floor finishing, offset from the walls, and one way. Note that all the part definition, all the faces, all the surfaces are stayed selected, and that is okay. I'm going to keep this at the moment on 1, step over, and of course I need to change that. You start from minimum because you want to go to 0, and then we set, I think we set 10 or 15 degree of maximum contact point, and that is not is percent, not degree. So basically it's not tilt measured in degree, but the contact point on the height in percentage of the full length of the flute. Okay, so in the collision control, I'm going to keep that as it is here. Linking parameters, I'm going to switch back to my cylinder, and I think I had it on 155. I'm going to select that again. Yep, 155. Okay, I'm going to change that to the 2 mil radius. Not sure what we had before. And rest of the settings are the same. Okay. So here we selected the offset from wall. I'm going to, after we regen the toolpath, I'm going to show that it works fine. We'll be doing parallel, and I'll show you 2 different methods. Okay. So again, I'm going to pause the video for 4 minutes, and let's see the result after. Okay, that was really quick. To be honest, it took a few seconds. It wasn't long at all. So as you see now, the pattern looks more like what we want. Okay. Okay, so we've got our pocket finished, the floor. Let's quickly go back to this pocket in operation, and I want to show you something more regarding the finishing the floor finishing. But before we finish this section, I want to show you something more. Okay, so I want to show you different options you have inside this pocket, multi-axis pocketing. Okay, so I'm going to copy this below. I'm happy with this result, but I want to show you so you know that you can use it in different ways. I want you to really understand how this pocketing can be used. So I'm going to leave everything here as it was before, but this time I'm going to change that to parallel, and I'm going to leave my guide curve as longest dimension. And I want to show you something, how you can actually find out of your toolpath what to change in the tool axis control. So let's select that, and let's have a look at the result. Okay, and this is the result. So what you can see here straight away, that our passes, our toolpath is trimmed on the sides, and they are not going all the way to the edge. So what should we change now? So the motion of the tool is going, so look at that. So if we go here, you see the tool can't go anymore because it would collide with the wall. And we are on the maximum angle range that we gave for lead angle. Okay, so basically in our case, if we want to machine the whole floor and avoid the collision with the side walls, we have to give Mastercam a bigger range on the lead angle. So we've got -10. So it is along the cut. So as you see here, the tool travels this way, and we have only 10 degree plus and minus, okay? So let's change it, let's say to 25. I'm not sure if it's enough or if it's too much. That's just a guess. But I want to show you how that will influence the path, the tool path. Okay. So now let's regen. And look at that. With one small change, the toolpath is completely different. And we machine from the wall to the wall, the whole face. Okay. So basically, if you see that your face is not machined completely, the floor is not being cut completely, that means it's something with your tool axis, the angles. Okay. And if the passes are shortened, that means it's your lead. If we do not have enough tilt angle, it would shorten this area here. Okay, so shorten the amount of passes close to this edge and close to that edge. So this is how you can use Mastercam preset options to use the longest edge as a pattern, or the walls, offset from walls. But there is something else that you can do, and let's have a look into that. So I'm going to copy this one this time because lead and tilts are okay on this. I'm going to copy this after, and I want to show you something else. So let's go to cut pattern, and here instead of longest dimension you can select a curve. But it should be select curves, but anyway, you have to select 2 curves, not 1, 2. Okay, and with this button, let's go to edge selection, and I can select this edge, I can select this edge, I can select even the edges that are not in contact with the surface. So for example, let's say I want to select this, even that way, with this. Okay, so look at that. I can even select edges that are not in contact with this floor that I'm going to select, but my pattern will be going, it will look like a morph toolpath. No, maybe not morph, but it will join in the middle. So let's see what this would give us. And of course, this is not something that I would use in this particular example. The offset from walls is perfect for this one because we have closed pocket and the pattern is going to finish the edges around the walls. But as I mentioned, I could use even this edge and maybe even this edge or this edge, and it will still generate the passes on this floor. Okay, so let's wait for the result. Basically, I could even use a wireframe and use the line and just draw a line here, draw a line in the back, and morph. And use my user-defined lines as my pattern. Okay, so this is what we get from these 2 lines. Okay, it's not too bad. It's not too bad, but however, I wouldn't use this for this example. Okay, I hope that I explained to you guys a little bit more how you can use the pocketing. In the last example, we used pocketing for roughing. Now we did walls and the floor, and maybe a bit later I'll show you how you can use to actually machine external walls. Okay, so it is not only pockets, it can rough and finish anything. This toolpath is very powerful. Okay. So I'm going to remove these two. Or maybe I'll ghost it, okay? I want to use only this one. This pattern is what I like. And let's go and give it a little bit tighter tolerance. Sorry, about a bit tighter step over. Okay. I'm going to pause the video. It's gonna take about 4 or 5 minutes probably. Okay, and that should give us very good finish. Okay, thank you guys for watching. This is all for today. I don't want to go and finish rest of the part because our video would become like 2-3 hour long session. And in the next episode we will program the rest of the part and we will talk more about this multi-axis pocketing. So if you like the video, please hit the like button, subscribe to my channel for future videos, and see you in